So displacement, velocity, and acceleration are all related to each other. We've seen that velocity is a change in displacement with time, and acceleration is a change in velocity with time. The fact that they're related in this way means that their graphs are related too. So in this first graph of displacement, you can see the displacement of an object with time, and you can see that the displacement is increasing, so the object is moving forward. And if we take a look at the slope tells us how the displacement is changing, what the rate of change is. So the slope of our displacement curve is actually the velocity. So if you want to know the velocity of an object and you have a graph of its displacement, you can look at its slope at any point and construct the velocity. In this case, we see that the slope is getting steeper and steeper, and so that means our velocity is increasing. Likewise, the slope of a velocity versus time graph gives us the acceleration. In this case, we can see that the slope is constant, and this implies that our acceleration is a constant value as well. So here we can see that there is this relationship. Since velocity is a change in position with time, the slope of a position graph gives us the velocity, and the slope of a velocity graph gives us the acceleration. We can work our way backwards too, actually, by looking at the area under the curve or line. So if we started out on the other side with our acceleration graph, and we considered some amount of time, let's say right here, you can see that if we look at the area under our acceleration graph at this instant of time, it would be this much. If, on the other hand, we considered a little bit time later, so let's call that time 1, and maybe this is time 2. At time 2, there's more area under the graph. And likewise, as we go along, if we go from the y-axis out to our chosen stopping time, there's more and more and more area. The area under this line gives us the velocity. And we can see that indeed, as we go from increasing time 1 to time 2, which would maybe be here and here, the value of the velocity is increasing, just like the area under this line is increasing. Also, we can do the same thing by going from velocity to displacement. If we chose a time and we look at the area under that line, under the velocity line, that area will give us the value of the displacement at that point. And here we can see if we choose some later time, then there's more area, and that corresponds to the value of the displacement at that later time. So by looking at slopes, we can go one way. By looking at the area under the curve, we can go the other way. Actually, there may be some starting velocity or some starting displacement that we need to worry about. But we can certainly get the rate at which it is increasing. So here is another question for you. Above is a multi-flash image of a puck's motion. So this series of images at the top of the slide. Which line on the graph below would show best the puck's acceleration? So in this graph, which one best represents the puck's acceleration? Is it the red line, the green line, or the blue line?